like to thank everybody for joining us today. So Ola Ahlqvist from Geography is here to present on work he's been doing with education and Geosciences gaming. So if you, as we mentioned in the flyer, if you happen to have the device with the Chrome browser, you can play along today. Ola also does work with the Service Learning Initiative on campus, and they're doing a coffee next week if you're interested in any of the work they're doing to connect with classes on campus. So a little plug for them.
Oh, thank you. Yeah. So thank you all. It's super exciting to be here in the midst of all the cool scientists. I was so excited, so I had to post that on my Facebook page, that I'm giving a talk to all the cool scientists. Okay, you've probably heard that before. Anyway, so who am I? I come from Sweden, and I got my degree in biology and earth science. I started working as a database developer, really, and then turned into ecology, and eventually found my way to a PhD program in Stockholm, and then started as a research faculty as a postdoc at Penn State, and then moved here in 2005. And my primary area in terms of teaching and research is cartography and geographic visualization. So this is my first observation, and I'm going to go through sort of an introduction to this area of games and how it can relate to geosciences. And that will be the part where you don't have to, I'm figuring you want some time to snack and get your fingers smudgy and so forth. But about 20, 30 minutes in, we're going to switch over. So those of you who brought a laptop can actually try to get your hands dirty on a game. So this observation, I think, is very fundamentally interesting, because not many people realize this, although more and more people start to realize that gaming is now the major entertainment industry in the world. It is sort of bypassed movies and other types of entertainment. It is huge. Let's see where I have. And obviously, what does that mean for everyone? Well, for starters, those of us, and I think most of us in the room, would associate our heroes with characters like this. Cool guys on the screen. Not so long ago, something really interesting happened. So there is this game called Tomb Raider that kids play in front of their TV with a little TV console, right? In that game, there is a heroine called Lara Croft. From that character, they craft a movie, which becomes a big, huge, successful franchise. And Angelina Jolie sort of impersonates Tomb Raider Lara Croft and essentially becomes Lara Croft. So from this game character steps out a real person who more or less becomes identified with this fictional character. Today, we see another sort of twist on this, turning this sort of full circle, where we have game characters who are real people stepping into the game, becoming these characters. So this is one of those professional gamers out there. This is by no means one of the most famous or richest or anything like that, just one in the crowd. Okay, and a few years back, he made $34,000 just playing games and promoting and doing all kinds of other stuff related to that. And the particular game he plays is called League of Legends. There are a couple of really big ones: Dota, StarCraft, First Call, those different things. But what does this have to do with the geosciences? That's what I'm trying to at least give you an idea of what it can mean. And this person, on the other hand, is all familiar to you. So when Al Gore gave his famous Digital Earth speech, for those of you who've heard, you're all aware of that, right? He talked about the digital Earth as this grand vision that sometime in the near future, a little kid can sit in front of a computer and basically just zoom into the world and find all interesting facts about the world and see models, how it works and everything. That was yet the vision. 10 years before that, there was a Yale professor, David Gelernter, who essentially expressed the same idea. But in this book about mirror worlds, he really pinpointed all the technologies that he saw on the horizon that would make this possible. And essentially painted what we see today is actually happening. With the Internet of Things, everything is censored. We can basically create this control room and know what's going on in the world, as if of a mirror of the world. Go back even further. There's a guy called Buckminster Fuller. Some of you are nodding. Yeah, he was a quirky guy, super bright, and had all kinds of ideas in his head. This is an example of what he did sort of in his spare time, the Fuller projection, which he argued was the best, of course. But he authored a book called Critical Path. And one of his ideas, visions, was this game that could be played on a model of the world, very much like the mirror world. But he saw this as an opportunity to simulate, not just mirror and look at, but also interact with, so that the game becomes sort of this giant model simulation of the real world where humans can go in and play with all the parameters that exist in the world. And this is something that he crafted sort of in his brains and did some huge model simulations with his students in the 60s, before it was even possible to wire up these computers in a network. So it takes a certain mind, I think, to come up with this. And we're just now starting to see examples of how this can actually look and start to see results of this happening. If we look on the internet and basically Google Maps and games, you will see something like this popping up. So these simple trivia questions, you go and you try to drag the states to the right place, and if you end up more or less in the right place, you'll get a little bing, or otherwise it'll duck, and then you'll try again. So that's typical of maps online, I would say, or map games online. But if you think of it, most board games are in some way or another spatial. So Monopoly is this super generalized abstraction of a city network, which is essentially a very simple circular topology with some familiar sounding names that you can sort of refer to some sense of reality. And then there is a certain amount of realism in it in terms of market economy and capitalism and all that. So it has some aspects of true simulation. Looking back, way back, you have these sort of command and conquer types of games where it's essentially about controlling territory, managing territory. Chess is the same thing. The Germans in the 1800s, late 1800s, started developing these Kriegsspiel, which was a way to teach officers about various strategies depending on the terrain and circumstances and the troops at hand and so forth. And this was very modular, so you can create different landscapes and then infuse it with certain types of troop configurations and so forth. And they started with these craft sort of looking things, but soon enough started looking at real maps and trying to play the game on a setting like that. Eventually, early 1900s, and people started having free time, sort of games for the public started becoming popular. And this is one of the first sort of popularized games that I guess upper class kids and their parents would sit and enjoy traveling around America and learn something about that. Here's another thing, more recent. Again, a lot about war and conquer territory. And this can be found in our archives, a little game, Admiral Byrd's South Pole game. And it's some sort of race to the South Pole in Admiral Byrd's footsteps. And I'm not aware of exactly how it works, history behind it or anything, but I went to go and just look at it, and it's just fascinating.
It will be the featured item in an exhibition in the library to open in a month.
Oh.
Perfect.
The rules there.
Perfect. Okay. So yes, games like this has been around, and a few years ago, I sort of wrote up this piece about this convergence of map making on one side and game making on the other side. And it looks as though it's these two things have sort of hovered side by side, maybe sometimes touched each other, but really gone different paths. But now it seems like all of a sudden this is converging in some interesting fashion. And a couple of points I'm going to touch at very briefly. Spatial analysis has been at the heart of both activities. So again, going back to chess, you can see a famous grid pattern. It's all about topology, how things connect, and connectivity. Huge in GIS analysis and map making, huge in the game of chess. It governs the rules and the way the characters can move. Fast forward into the modern digital game world, we see similar types of building blocks, in this case hexagonal building blocks, that contain some basic features and abilities to move across and so forth. And again, the topology of them is what governs the entire structure of what can happen in this game. As geographers, we often spend time doing spatial analysis, looking for density patterns, clusters, and things like that. Modern gamers do the same. So in many of these big games with lots of users, they collect data about what's happening in the game, and all of a sudden they can see patterns in terms of what's going on when a particular type of sniper is equipped with this particular weapon. Where do the most kills happen in the game? In order to sort of hotspot danger zones, if you're facing that type of opponent, you want to avoid those areas because they're extremely vulnerable, right? So again, we're seeing this borrowing ideas back and forth, but it's not clear how much of real borrowing is going on or if people are reinventing things as we go along. The second area is the area of really computer development and the web, and in some sense related to simulations. These are really old school Moonlander, Pong types of simulations. They went pretty quickly into the Nintendo world, becoming less one player, more two player, several players, socializing together, and today have turned into an entire industry, as I talked about in the beginning. So these are big game competition events where tens of thousands of people gather around the world to watch a group of players duke it out in one of these games. And as I said, they attract live crowds, so you can see those players up on the stage, I think somewhere over there. But most of the stuff is happening on screens, right? Big, huge jumbotrons. And obviously streamed online so that even more people can tap into this. And has more or less the exact same dynamics as modern sports. Exactly. They're basically mimicking it to create revenue. So a few notes might be at hand at this point. When you think about playing games, it's usually voluntary. People buy into this just out of sheer pleasure or maybe the sort of slim opportunity to gain some profit from it. It has a lot of make-believe aspects. So there's a lot of fantasy sort of entering this realm of the unknown and maybe it's the virtual. It's really motivating intrinsically. The game itself is built to be motivating. So just becoming subsumed into the game dynamics is enough to keep you in there and continue to try to improve, to do this, to do that. And also the interesting thing I think is that many of them include maps of some sort. So they're often spatial in some way. And it has been shown that gameplay can promote much higher level thinking, problem solving, social interaction, and collaboration. A lot of the things that we do as teachers and educators want to, instill in our students. So we're witnessing a little bit in terms of the digital gameplay, a fairly dramatic transformation where we go from the kind of passive watching of media and instead entering media and becoming engaged in its construction and co-creation, and this sense of third place emerges, where essentially you're your activity takes place somewhere else, even though you're in this room and your opponent may be in the other side of the world, you're collaborating and working together in a third world, in a sense. And that becomes reality in a very tangible form. So, about increased realism, these are two pictures of Pittsburgh. One from Google Earth, one from a game engine. And this is what I mean with converging worlds. All of a sudden, the game engine starts to import the world, and in order to play whatever game that it is in the real world, in a way. And our real world simulation or environments are becoming more and more realistic also as a depiction of reality. And also, if you think about what happens in these game situations, particularly when you compare modern drone warfare with games that simulate, going to war in Afghanistan or something else, the difference is minimal in terms of the user experience. You have similar person sitting with their headset in front of a set of screens. That's where everything happened. That's the sort of the third world event space, when the real thing either doesn't happen at all in reality, or in this case, actually happens in reality. So if you think about the interface as where all this is happening, it's just a matter of what you do beyond that interface, whether it's real or not, right? So this idea of designed worlds is also an interesting pattern where we see lots of games creating amorphous versions of the world map in order to create the game, make the game more exciting. We can kind of tweak the world, do the Monopoly map instead of a real map and so forth. So that's kind of basic stuff around games, but because it allows many of these game design engines allow regular users to go in and tweak the world that they're playing in. Again, you're being more involved in the creation of the game. You become a constructor of the game, designer, if you will. And to a point where you see examples like the Ordnance Survey putting out an entire Minecraft model of the UK made up of 83 billion blocks representing the entire sort of mainland portion of Great Britain. And they give it to you for free to play with. So here again, you get this big model based on Ordnance Survey real data about roads and houses and different types of vegetation. And all of a sudden you can Minecraft that and play around with it as if it was real or not, or if it was just for fun. And the final step, or the final thing I want to mention, this is probably maybe where people like you would find this a little bit interesting, is when games are used in various types of scientific simulations. I've provided one example here of land use, and there are a couple of research groups out there, one in France, that does in-depth studies with local stakeholders around scenarios in their own environments, around a village, for example. What might be the different options for developing, doing new types of crops and things like that. So they engage in sort of a simulation game style exercise, which they then pull out and try to extract rules from, or some kind of ideas of what is going on in these people's heads, and then try to code that so that they can implement a software model that replicates real people's thinking. So you can sort of start producing agent-based models of land use and land tenure behaviors based on real actors, but imported and translated into software, and then can be replicated and tweaked. And you can change the parameters a little bit and see what happens then, instead of boring all those people with repeated gameplay. We did a little experiment like that with a master's student who did the same thing. He went to Cyprus and played a similar land use game with farmers on the ground, and then brought it home to Ohio State and had students play the same game and just looked at the outcomes and comparing non-expert players, sort of the farmer expert, with just a regular student, and saw that the farmers did a lot of irrational things. You know, from a game perspective, it wouldn't make sense to plant oak trees or olive trees. But they have done it forever, so they wanted to do that even if it didn't gain them any advantage in the game. Whereas the students immediately realized that this is not not gonna waste my resources on that. This will give them the profit and so forth. So you can see how, you know, coding for that type of behavior, irrationalities and things like that, would be really hard. And it would be culture specific, so you never know how to code for certain things that may be different from one valley to the other. So in the midst of this, we got this idea that we might be able to wrap some kind of multiplayer environment around an online GIS. So the goals of this was to develop some type of fun game that embeds some type of geographic learning. So we wanted it to be multiplayer capable, so we could have hundreds of users tap into it at the same time. We want to simulate this play on top of a true GIS, so we could bring in any data that was available on demographics or land cover or climate patterns or anything, even historic data, and then allow for players to have interaction amongst themselves, to be able to collaborate, and also be able to flexibly modify the rule set so we can sort of tweak the rules a little bit, see what happens in the game, and so forth. So this is just stepping through a couple of prototypes that we've played with, literally. This one was Google Earth API when that came out, sometime 2010, I think. And then a Microsoft Surface Table experiment. And this was interesting from not just the coolness factor, but every time you started the game, it pulled real weather information from NOAA. And the weather actually influenced how you could move around the map. So we said if there are storms or anything like that, you couldn't cross that area without moving around it. So from that, and also the troop reinforcement is kind of a risk-style game. So that would take information about GDP and population instead of just being some kind of number. Okay, so we wanted to show that we can use our own data, we can use anyone else's data just sitting there and just pull it in the game and start playing with it. So this is a fourth prototype. This is the full-bodied version, the first time we really pulled everything together in one interface. We used it a little bit in one of our classes. And eventually, in I think 2009 or 10, I was able to pitch this idea to Esri, which essentially led to us being able to land this NSF grant that's kept us alive for 5 years now. And the question we have in that project is, given this technology, which is entirely new, you call it a new genre, if you will, a game played on top of a GIS, how do people really learn with a technology like this? What is it about it that makes learning happen? And what is it about it that is unique and different from, let's say, SimCity or some other off-the-shelf thing? What is different? So we use this in our classrooms. We do user evaluations, and we talk to instructors, we talk to students, and look at what they're doing and in order to try to extract information from it. The general idea of the game is that it's a farm game set in India. It's supposed to give the player a sense of what it's like to be a farmer in the context of the Green Revolution. So become a farmer, face the opportunities of either do traditional farming with land-raised seed and no particular fertilizer input, no mechanical labor and so forth, or use capital-intensive things like fertilizers, like improved seeds, and mechanized labor, irrigation systems, and so forth. So you have a little bit of a starting capital. You can get land. You can buy different assets if you decide, or if you want to just do the traditional thing. Once you have your return, you can sell that on the market, and the cycle begins again. You have your family to think of. You need to feed your family. There may be births in the family, there may be deaths in the family, and so forth. So it's a little bit like Farmville, for those of you who've played that. So I'm going to return then to my presentation and try to walk you through a few pieces of this game. What will happen when you open this game is essentially you see this game board. You will be able to see a village in India. The backdrop map is the regular Esri imagery that you would find just going to one of those digital Earth platforms. You can zoom in as much as you want. You can move somewhere else in the world if you want to, but this is now situated in India. We have created an extra layer on top of that. That's our game board. And it's essentially a set of parcels, land parcels that we try to just digitize on top of the existing world and calculate the areas so that every place has an area in terms of acres. And then the player can decide whether they want to buy this, and once they've bought it, they can start planting. They can decide if they want to plant landrace or enhanced seed. They can decide if they want to fertilize at a certain level. Anything of these choices will have a cost. So it's a matter of balancing what you have in your coffers with what you can expand on. You want to buy more land and plant landrace seed, or a little bit less land and invest in fertilizers and the enhanced seeds and so forth. You also have to think about managing the land, because all of these new technologies also comes with somewhat increased labor. And only your adults in your family can work the land. The kids are sort of kids until they're 10 at least. And every growing season they grow 1 year and so forth. So eventually you get more adults in your family and you can farm more land, or you can hire. So if someone has 4 adults in their family and only have enough money to buy 2 acres of land, they can lend their labor, sort of surplus labor that just goes around and does nothing, to someone else who needs it. And everyone sort of plants and do their thing until the turn changes. And it depends on whether that's timed or if it's that everyone agrees that let's switch turn. And then there's a calculation based on a random weather index, and then calculates the outcome based on what you've put on your land, how much fertilizer you've put on there, and so forth. This is a straightforward deterministic formula. And then you get the output. You can sell that on the market. You may want to buy an ox to help you plant more land and grow larger acres. It costs you initially, but after that it'll be sort of a return on investment. So those are the variables that go in, and we run this for any number of times. And in the educational context, yes?
What happens if 2 players want to buy the same lot at the same time?
You can't.
Who buys
No,
it?
it's instantaneous. So if someone clicks on the land and say buy, if the other one is a fraction second too late, it's gone.
It's not a turn. Like,
No. So some of the things that happen are instantaneous, but in terms of the turns, they sort of, within any one turn, you can do certain things. And then once the turn changes, that's when you can't do anything more, and that calculation happens, right?
Is there some type of counter or something that tells you when the turn is coming up?
So right up here is a timer. This is the turn number. So it kind of keeps track of that if it's timed. And sometimes it's not, but just based on everyone kind of flags, I'm done, switch, and it waits for all the others to come together. So that's the overview of the game. And this is the point where I think I wanted to sort of throw in, why are we doing this? It's not just to create this educational fun activity, because that's sort of the focus of our current grant. Look at what type of, education can happen. Quay here is an expert in education technology, and we've worked on ideas for other proposals on the educational aspect of this. But we're also thinking about what can we do in terms of simulating things with this. Because we can draw from this massive multiplayer environment. And remember back when we looked at that map of densities of shootings and killings. We can do the same thing with our map, but it will be yield, average yield across the map. Where people tend to farm, where the users tend to plant landrace versus non-landrace. And you might think that's not, it's just anywhere, you can plant anywhere. But as soon as you insert a rule saying that, like we're doing now, the distance from this river makes it more difficult or more costly to install irrigation. So obviously people will start to acquire land closer to the river. It will also matter if you plant the same plot of land and fertilize over and over again, it'll wear down the soil. And so after a while, the game will say, no, you're not getting the full return because you start to wear out the soil. You have to create some sort of rotation here. So we're inserting those kind of things, and basically, and the water flow too, even if you're close to the river, if you're upstream or downstream matters, if you can pull all the water from all the people who are downstream, that's your advantage, right? So we've started also inserting those types of things, and that's where the GIS model, or the GIS underpinning makes the difference. Because all of a sudden we can use existing scientific model developed for a GIS system. We can simplify them and essentially let them sit in the background and wait for our game to ask, okay, we have this river, we have this flow, and now we have X amount of withdrawal from it. What happens with that river? We send that river over to the simulator, it gives us back the numbers, and we give that back to the players. This is what happens in the real world. So if you think about it, you can do those types of real world processing with lots of the actions in this game. You can take the market, so if everyone is getting huge surplus from their crops, let's throw in a simple economic model, demand, supply. All of a sudden the market is flooded with supply, and the prices will go down. So you won't get as much benefit from generating all that surplus crop. So the payoff from investing all of this money will not pay off as much as you thought. And that's again becomes both a learning experience and a reflection of what would happen in the real world in some sense.
Have you put like weather extremes, the real-time weather extremes, or maybe long-term changes in
Right,
conditions like
that's
drought?
exactly what we want to do now. So the next step, talking to Alvaro here, trying to come up with what might be some simple repository where we can grab historic weather data from anywhere in the world, basically saying, okay, we're here. What is the closest place we have some weather record historically, for example? And pull that information, turn it into some type of drought index, and let that influence what the outcome will be. Obviously modified by the amount of water you were able to draw from the river and so forth.
So can you make the river flood?
We could theoretically do that. No, absolutely. I mean, it is possible pretty much to do anything in this game that you can do in the GIS. Theoretically, that's possible. It's just a matter of how do we come up with it and can package it in such a way that we can define it as a web service in technical terms. And it's essentially like a lemonade stand waiting for an order. So if we sort of address that and say, we want to know whether this year was flood prone in this area, or whatever that request will have to give, and then we can get those answers back from true science data.
Well, I've been long intrigued with this idea and tried to spin up some proposals directly along that line. I'm just curious how far you've come with, say, a reflective component in your educational process. Do you show actual scenarios back to your students? What output do you have that gathers kind of decision-making scenarios to show, like you showed us that example,
Yeah.
that war game, right?
No, I think
Where spots and kills are.
that's a great question. So what we try to give the students is direct feedback on their immediate output. So in terms of, so this is your yield this year. The weather was like this, and the market gave you this much for your for your crops. This meant that you had this amount of surplus this year. Exactly how to present that is turning out to be really tricky. Present it in a way that is intuitive, understandable, and so that they can start thinking, oh, now I see a pattern here. And I think that's the big problem that we're having right now, to figure out how that learning can happen more effectively. Because at this point, I wouldn't say that this game is any superior than if you played it as a board game and sort of worked the numbers yourself on a spreadsheet, a little sheet of paper. But it's a matter of, so what can this, obviously we can add much more simulation and all that. So if we can get the same result, but with a much more adaptable and maybe dynamic, then we've gained something, even though we didn't gain in learning. We gained in flexibility, right? So one of the things I want to show you this. This is something that NSF really forced us to think about when we started this project, because we went in thinking that this was the type of assessment we wanted to do. So we wanted to see students come in, they do some little survey ahead, and then they play, and then we check after the fact, did they learn something? So if we do that typical summative assessment, we would be able to determine that learning happened. And it would probably be some kind of gain. The problem from the research perspective, sort of learning science perspective, is what was it that made learning happen? Because this is our game. If someone want to create a similar game or something else, what can they draw from in terms of experiences to make sure that their game implements some of the most effective pieces that help learners to get to a higher level? So what we need to do is do this formative assessment. We need to poke as learning happens and try to see where is something triggered. What is it about a certain change in the game? For example, at some point we had small probes inserted as they were playing. So between turns, there was a little question coming up. So what's your strategy right now? And they have to answer, in a sentence or so. I don't know. Or, yeah, I'm trying to use all my money to buy fertilizer. Something like that. And so by looking at those answers over time as they play the game, we can start to see sort of how long does it take for them to start thinking differently and maybe at a higher level about what they're doing. And then maybe changing the way that reflection happens. So recently we changed from just doing a long 20-turn gameplay and chunking it up into 2 sections. So they play alone for 10 rounds. Then they get into a discussion forum, and they're faced with a critical question about, so what do you think the Green Revolution gave? There are 4 answers. None of them is really right or wrong, and they have to argue with the other students why they think this is. Then they return to the game, and then we can sort of assess their learning after that. So by modifying different versions of the game, we can start to see what strategy is most effective in terms of generating learning in an environment like this. So that's what we're trying to do, if that makes sense.
Could it be, so a lot of times the traditional approach is to use this to educate maybe farmers or students. Can you see it used in a different way where there's been small, experiments around the country where the medical community have given doctors cash to go ahead and wager where they think the hotspots will be for flu outbreaks? And can you see using this as a situation, you actually put a bunch of farmers in a room, have them play the game with 2 different groups, 2 different policies, and then you basically see how the policies actually would play out in the future based on their feedback, and then you can say, this seems to be the more effective government policy to protect the watershed because it resulted in less nutrient flow in the river.
Absolutely spot on. That's what I think this can do. So you can enact the rules in the game are basically policy. And by tweaking the rules, you can say that, well, the government will go in and subsidize. And currently we actually have a subsidy. So if you turn dirt broke in this game, the government goes in and gives you some cash in order to at least start over again. Turns out that people kind of just scrape at the bottom, which is kind of realistic, unfortunately. So yeah, it does give just too many opportunities for my brain and our environment to deal with. And that's where I think the exciting part of this technology is. It's really just now starting to form and take shape in this way. And I hope that more people around, will come up with other solutions and start thinking in these terms and see what can be done.